So far we've already looked at Hooke's law, its formula and its effect on elastic objects, and now we're ready to look at some questions. So the first one here says calculate the spring constant. Okay, so right away you need to be thinking, well, this is Hooke's law, what's my triangular formula for that? Okay, and it comes up as force equals constant times extension, and that's the general formula, and you just need to cover the value that you're trying to find each time when you're asked a question. So in this one here, we're trying to find the spring constant. Okay, so we're trying to find this. So we're going to put our finger over the constant, and that gives us the formula that we need to be using today. So we're going to be using the constant equals force over extension. Now we know that our force is 5 newtons, and we know that the extension given in the question is 0.075. So we can slot that into the equation. So K now equals 5 divided by 0.75, 0.075, and we get an extension of 66.6, but we can make that 67 to 1 decimal place. So that's the first part done. Now we'll move on to part B, and it's asking us now, what extension would 5 newtons give us? So we know that that has increased by 10 newtons, so it's going to be a longer extension. We need to find the formula that we're trying to find. This time we're trying to find the extension. So if we just cover the thing that we're trying to find here, which is the extension, our formula is going to be using the force and the constant that we've already found. So we're ready to write out that, and we will do the extension equals force divided by the constant. Our force is now 15, and our constant we've worked out already is 67. So if we just slot that in, we know that the extension equals force divided by 67, and we put that into the calculator, we now get 0.22. Now the thing here to remember is to put in your units. They've asked us for extension, and the extension was given in meters, so we need to add a small m there for meters. And finally, part C, if the original length was 0.1 meters, what would the total length of the spring be in part B? So now again we are looking just to put all the facts that we've discovered already and answer part C. So we have the original length was 0.1 meters. Then we have 0.22 meters is the extension, and we find that in part B. And if we add those both together, we get a total length of 0.21 meters. Don't forget your units, and that's the total length. So now we're ready to do question 2. And question 2 is asking us, just read through what you're being asked first of all. Could you get all the clues that you're looking for? The first one here is saying an upstretched spring. That's just being awkward. That means that the spring hasn't been stretched yet. Okay, so it starts off at 0.5 meters long. Okay, so that is before stretching. Sometimes the examiner just likes to be awkward and ask you silly and put in silly words, but upstretched means it hasn't been stretched. The key thing here is that the fact is when it was pulled, and that gives you the clue. So when it is pulled by a force of 12 newtons, always underline your information, it stretches to 0.56 meters. So we are being asked, what is the spring constant? And to work that out, again, just always have in your head the triangular formula related to the topic that you're studying. In this case, it's Hooke's law. Hooke's law is force divided by or over constant times extension. And put down the facts that you know, okay? So the force is equal to 12 and the extension is what, okay? Now it said here it stretches to 0.56, so don't be putting in 0.56. We want to know how much it had stretched by. So we have to do 0.56 minus the original length, which was 0.50, and we get 0.06 meters. It stretched, or the extension extended to 0.06 meters. Now we're ready. We've got our two pieces of information. We can find the third, and we are looking for the spring constant. So remember, put your finger over the thing that you're trying to find, which is the K, which is constant, and we get force divided by extension. So it's very important you get your marks for physically writing out the formula. So K equals force divided by extension. Now we know that our force is 12 and we've worked out our extension is 0.06. And if we just slot that into the calculator, we will get 200. Now, we can't just leave 200 on its own. We need to give it units, okay? And the units here are, we have meters in the question and we have newtons in the question. So we are going to have 200 newtons per meter. Okay, and I'll just go over where you're getting those marks from. Number 1, you've given the correct formula. Second point, you've slotted in the correct values. The third point is your answer. Sometimes they give you 4 if they haven't given you the units. Most likely they will give you the units. So now we're ready to move on to questions on your own. Try those yourself. So I want you to try questions 3, 4 and 5 on page 3. Don't do question 6. That's really a higher tier question and there's no point in confusing you with everything. So just try 3, 4 and 5 for me. Thank you.